Good day, grade 12s. I hope we are all fine. You are still practicing mathematics and preparing yourselves for this coming trial examination as well as the final examination. And now today we'll be doing technical mathematics, and the topic that is going to be part of this lesson is analytical geometry, as you can see on the screen. And then before we can start our lesson, once again, make sure that before you go and write the final or the trial examination, try to have examination guideline, go through it, and then try to check under analytical geometry what are the important information that you need to know for this topic that we are going to be doing for this lesson. And it's very important. And as you know that this is part of what? This topic is part of paper 2. And then we all know that when it comes to paper 2, learners, they really struggle to get good marks on that paper. So, but please, if we can just put ourselves into a very specific way of practicing mathematics, I think it will help a lot. I think that is all for today's information. But now let's get into our business for today. Under content, let's see under content what we're having. All right, now under content, we have, as I've said, that the analytical geometry, and this topic is from part of paper 2, which is 25 plus or minus 3 marks for paper 2. And then under analytical geometry, we have to look into linear analytical geometry, circle and analytical geometry, as well as what? As well as ellipse. So those are 3 concepts that need to be revised thoroughly, so for trial examination and the final examination. So they are very important. Make sure that you understand the important things that you need to learn or understand under this linear analytical geometry, as well as the circle, and of course the ellipse. Then from there, I think you will be prepared to go and face for paper 2, right? And then let's see under linear analytical geometry what we are having. All right, before then we can now discuss the linear equation formulae. The first, we've got a formula for distance, and then let's look into the distance formula there and see. All right, I think the system is very slow, but it will come. All right, now we can see that this is the formula for distance formula. And then it's very important to understand on how do we calculate using the distance formula, but there is no need for you to memorize this formula because they are there on the formula sheet. You just have to understand when to calculate the distance formula there. And then we went to the midpoint formula. And then the next part about this one, it will just tell you straight that calculate the midpoint of this, or calculate the distance of point AB. So you just have to take the correct formula there and then you substitute, and then from there you get your answer. And then we move to the gradient. Then we're going to talk more about the gradient at a later stage because it's very important, the issue of gradient. And then from there we have the linear equation. So when we are calculating the equation of a straight line, or when we are calculating the equation of a tangent, so this is the formula that we are using, where y1 is the value of y on the point that we're going to use, and then m, of course, is the gradient. Hence I said the gradient is very important. All right, and then angle of inclination, then it's going to be tan theta equals to the gradient, right? Changing y over changing x. So the gradient is also the gradient. So if you don't understand the gradient, then there are so many things that you are not going to be able to answer if you don't know that. Now we move into perpendicular lines. Now remember, when we are having, for instance, AB is perpendicular to CD, then the gradient of AB multiplied by the gradient of CD, the product must give you -1, right? Meaning two lines which are perpendicular to each other, their gradient give us -1 when you multiply them. And then the last one, which is parallel lines. What do you know about parallel lines is that the parallel lines, the gradient of two parallel lines, they're equal. We can see that AB is parallel to CD, therefore the gradient of AB equals to the gradient of CD, right? I think that is that. So those are the formula that normally we use when we're calculating a question under linear equations, right? So it's very important to understand on how do we calculate using those formula. Now let's get into a first example under analytical, and let's see what we're having. All right, now we are having a scenario, and let's see what we're having in the diagram below. Let me take my pen first. In the diagram below, triangle ABC has a vertical A, which is 6:4, B is -2:2, what is to 2, and then we have what in C, which is 6:2, and then in the Cartesian plane, the angle of inclination of VC is theta. You can see there's angle there, which is theta. Now, the first question that we need to address is, say, determine the coordinates. The coordinates of the midpoint D of AC. Meaning, we need the midpoint of AC that will give us point D. So I think it's somewhere here, right? In the middle of this line, there's D there. Then we have to calculate the coordinates of that D. Then, of course, since the midpoint, then we're going to take the formula for midpoint, as we can see on the screen, that YXA plus XC over 2, YA plus YC over 2. Then the second step, you just substitute your values. You can see that XA, the value of X on point A is 6. And then XC is what? Is negative. How much? XC is 6 as well. So it's going to be 6. All right, divided by 2. And then YA is 4. And then -2. You can see it's -2 there. And then from there, you simplify it, then the answer is going to be 6:1. Meaning these are the coordinates of D. The coordinates of D is 6:1, the midpoint of AC. Then we go to number 2, determine the equation of a straight line. Determine the equation of the straight line BD. Where is BD? Remember, BD we have determined, I said that point D is in the middle of this line. So we can just try to write. Let me erase that. All right. So it's from this point here up to this point. So they are in need of what? We have to calculate the equation of that line. Now, for you to be able to calculate the coordinate of line, we need a gradient first. Then let us calculate the gradient. Then now we are calculating the gradient of BD. So that is the gradient, and then the gradient now is -1 over 8, right? Now, for you, remember when you calculate the equation of a straight line, we need the gradient and the point, right? Now we have just calculated what the gradient, We need a point. Now you can choose between point B or D, which one will you use. So any point is going to give us the correct equation. Now you write the standard equation for straight line. Then you substitute. You can see they have used which point there, which point that they have used. I think that point is point B. You can see is point B. Coordinate of point B, you can see is equals to -2 is to 2, right? -2 is to 2. Now you can see this one is a -2 there. Then there's a typing error there. It's supposed to be 2, not 1, right? Let us try to fix that. This is 2, okay? And then now it's going to change. It's going to affect the next step, but we'll try to fix the next step there. Now, when you open the bracket with this -1/8, this is going to give us -1/8x. Then when you multiply -1/8 times 2, then it's going to give us -1/4. Supposed to be 1/4, not 1/8, right? And therefore, when you transpose this -2 to the right-hand side, then it's going to be +2, right? And then let's see on how do we get that. Then we'll have to calculate or recalculate and then since we are no longer having 1/8 there, the correct one is -1/4 plus 2. Then meaning this is not correct. Then we'll have to write the correct one. So the correct one is going to be, I think, 4 down here. It's going to be 4. Let's say check how much we can get. And then when you take a calculator and say -1/4, -1/4 plus 2, then it gives 7/4. So the correct answer is +7/4, not 15/8, right? There was just a typing error there. Instead of writing 2, we used 1, and which is wrong, because now you can see the point B is -2 is to 2, and then the point D is, of course, 6 is to 1, right? So we have used this point B. So this is 2, all right? And then I think we have answered everything. Now we can just proceed. Example 2, let's see what we are having under example 2. All right, say P is -2 is to -4, and Q is -4 is to 2, and the last point is R, which is 7 is to -1. You can see this is Q there, and then this is P, this is point R. Vertical of triangle PQR in the Cartesian plane as shown below. Theta is the angle of inclination of what? Of PQ. Now the first question says, prove that triangle PQR is right angled. Prove that, we have to prove this triangle is right angled, right? And then let's see on how do we do that. All right. Now first, if we can just multiply the gradient of PQ, the gradient of PQ and the gradient of PR, if it gives us the product of -1, then you will know that this is a right angle triangle, because remember this formula is for what? Is perpendicular lines, meaning if this line of QP is perpendicular to PR, it tells us that where they meet, there is 90 degrees there. And then we know that a right angle triangle is a triangle that has 90 degrees. Now, but only if the product of those gradients give us -1. If not, then that triangle is not a right angle triangle. But now they say we have to prove it. It means this is a right angle triangle. We just have to prove it. Now we are going to prove it how? Using this method of perpendicular lines, where we are going to multiply the gradient of QP multiply by gradient of PR. Then we must get -1. Now let's see if we can calculate that. All right, this is the gradient of what? Gradient of QP, and then you can see, and then this is the gradient of PR, and from there we can now substitute the values, and then press your calculator and see how much you're going to get. Then the answer that we are having now is -1, and therefore triangle PQR is a right angled triangle. All right, so that is how you should prove that a triangle is a right angle. You multiply you multiply the gradient of two sides, and then if they give us a product of -1, then it tells us that that triangle is right angle triangle. Number 2, calculate the area of triangle PQR. Calculate the area of triangle PQR. Now let's calculate the gradient. The area. Now the distance of QP and PR. Now we are in need of the distance of this side and the distance of this side, right? So we need the distance now, so that we can say the height. We can take this side as the height. We can take this side as what? As the base. Then it's going to be easy for us to calculate what the area. All right. Now we're going to write the distance of PQ there, and then it gives us what? It gives us 2 square root of 10. There's 2 square root of 10, and then from there we are looking for distance of PR. So that distance is 3 square root of 10. So we have the distance now. So since we have the distance, then we can now calculate the area, and then our area is, area of the triangle is half base times height, and then we have half, and then base, meaning we take this one as a base, and then we take this side as what? As height. And then that's how you're going to substitute them. Then you just press your calculator, and it's going to give us 30 units squared. All right, 30 units squared. So it's very important to write units squared to show that you are calculating the area. Okay, I think this is the last part. Now we can just go to the next question. Let's see the next question. The gradient, the diagram below is a parallelogram. We are told there is a parallelogram, vertices, which is A -2:2, B -4:1, and C is 2:0, and D, of course, is X and Y. So we don't have coordinates. You can see point D there. And then alpha is the angle which AB forms with the x-axis. And then M, which is 0:1, is the midpoint of AC. Is the midpoint of AC. The first question that we have to address is to determine the gradient of what? AB. Let's determine the gradient of AB. Gradient of AB. And then you just calculate the gradient there. Then our gradient of AB is what? Is 3/2. That is the gradient of AB. So it was quite easy to calculate the gradient because we know the formula to calculate the gradient. So we are having points there, then it's easy, right? The next question, determine the equation of DC in the form of this. Let's go and look for DC. Now we can see that the distance DC is this one. I mean the line that we are calculating for that equation is DC, is this one. Now remember earlier on I did explain that if you are in need of equation of a line, we need two important things. First, we need a gradient. Second, we need a point. Now we can see that from this line, we are having only one point, which is C, which is 2 is to 0. Then if we had a point at D, a coordinate, then it's going to be easy for us to calculate the gradient, and therefore we choose between D or C, which one you use as a point. Now, so how are we going to calculate that? Now, let us study this gradient of DC equals to gradient of that. Now, we are told to remember this A, B, C, D, it's a parallelogram. And then one of the properties of the parallelogram is saying opposite sides, they are parallel, right? Opposite sides of parallelogram, they are parallel. So now, and then we have learned about the gradient of two lines which are parallel. What are they saying about that? They are saying they are equal, meaning the gradient of DC of this line is equals to the gradient of what? AB, because these two sides they are parallel, right? So they are equal in terms of gradient. Now we can see that the gradient of that line that we are looking for the equation is 3/2 because we have calculated that gradient from first question there. It was 3/2, all right? And then the point that we're going to use is point C, which is 2 is to 0. That is the only point that we can use because it's the point that we are getting on this line. Because D, we don't know in X value there, we don't know Y value there. So it's not going to be possible for us to take point D. All right. Now, since we've got the gradient and the point, then now we're writing the standard equation for straight line. And then we then substitute your values there. This is how we're going to then, I guess that we open the bracket with this 2/3, then it's going to give us what? 3/2x minus 3. So this is the equation of line DC in the form of mx plus c. So we have answered that question. Now let's proceed. The question still continuing. Right. Okay. Now the diagram below is still the same. It's a parallelogram. We're still having the very same question that we just did. And then we have the new question, which is determine the size of alpha there, which is this one. We need the alpha there. Round off to 2 decimal place. And then first we have the gradient. We have the gradient of this line. For us to be able to calculate that angle, we have to get the gradient. Now the gradient, remember earlier on we have calculated from that line AB, which is 3/2. And then from there you divide with that tan, then it's going to be this. So it's going to be shift tan, and then it's going. Then you put this 3/2 there. Then it's going to give us as 56.31 degrees. So that is the angle for alpha there. I think we can now proceed to the next question. Determine the coordinates of point D. Coordinates of point D. We are now calling the coordinate of point D there. Point D. Then let's see on how do we go about it. How do we calculate that? Let's see how do we calculate that. All right, now before I can explain to this one, let me come here. Now remember this ABCD, we were told it's a parallelogram, and I believe we all remember the properties of parallelogram. Now you can see that the midpoint of AC is at this M, and then the midpoint of DB is M out as well, right? And then we know the distance, this equals to this one there, and this equals to this one there. So these are the properties of what? Of the parallelogram. Now, since M is the midpoint of both lines, line AC as well as line BD. So M is the midpoint of those two lines. Now we're going to utilize use this M as a midpoint to calculate the coordinate of D. Now first, we're going to say the gradient, the midpoint of what? DB, the midpoint of BD equals to XB plus XD. Then we start with the X first, divide by 2. Now, what is the midpoint of that line BD for X value? You can see from this point here, point M, it's 0 there. I think it's 0. Let me just remove that line so that you can be able to see the. All right. You can see that the midpoint is 0 there. The midpoint of DB 0 for X, and then the midpoint of what? Of Y for point D and B is 1. Then the next step is what you're going to get. 0 there. The XB you can see is -4 plus XD, which is what we're in need of, divided by 2. And then the midpoint of BD. The midpoint of BD for Y is 1. Then YB is -1 plus YD is what we are looking for, all over 2. The third step, then you're going to cross multiply. If you cross multiply, this is what you're going to obtain. So you have to multiply this is what you're going to obtain. Now here we can solve the value of X there, because you can now transpose that -4 to that side, then it's going to give us +4, and then as well as this one is going to give us +3. Now the coordinates of D is 4:3. The coordinates of D is 4:3. So that's how you should go about it. And then let's proceed. I think this question repeats itself. Then we don't have to do this one because we did this question earlier on. We just did this question because we determined the value of alpha there. It was 56,5 something. All right. Now let's move into circle analytical geometry. Circles. Then we'll be looking at what? Finding the equation of a circle in the form of x² plus y² equals to r². Then we'll be looking at determining the equation of a tangent to a given circle where gradient or a point is given. So these are the two important parts that we'll be looking at under circles and analytical geometry. Let's get one first example. In the diagram, in the figure below, O is the center of the circle. P and Q, Q is 12:5, are points on the circumference of a circle. POQ is a straight line. The point R lies on the tangent to the circle at Q. You can see that we have a tangent there, and then we have point Q and R on that line. All right, now the first question, determine the equation of a circle. Now let's see on how do we determine the equation of a circle. First, you write the standard equation for circle, And then because we are having what? We are having the point on the circumference, which is 12:5. And then we're going to take it as x and y. Then you can see for x, we just substitute with 12. And then y is what? Is 5. That step, then we can see 12 squared is 144, 5 squared is 25, r squared. And then the last part, you can see that r squared is equals to 169, because now we don't calculate radius. There is no need for us to calculate the radius of the circle. Just after arriving at this stage where we have r squared, then we can just stop there and write the equation. Our equation is now x squared plus y squared equals to 169. So that is the equation. So you can see there was no need for us to calculate the radius in this one. And then the next question says the tangent, determine the equation of a tangent RQ in the form of that. Now remember, the same applies with the straight line, because a tangent is still a straight line. We need a gradient and a point in order for us to get the equation of a tangent. Now we can see from that line, we're having only one point, which is point Q, where we are having 12:5. Now, how are we going to get the gradient if that is the case? Now, first we need to have the gradient and a point. Now, of course, point is quite easy. You can take this point Q there because it lies on this line that we need the equation of that. And then from there, what you're going to do, then you're going to calculate the gradient of OQ. This is O, meaning the gradient of this line here. Remember, the coordinates of O is 0:0. We've got the coordinates, and then we've got also the coordinates of Q, which is 12:5. Now, after substituting, then our gradient is 5:12. And then the point, of course, we're going to use 12:5. And then, now remember, this line, which is from center of a circle to the circumference, and then it's going to be perpendicular to the tangent, right? It's always the case that a line or a radius is perpendicular to tangent always. So we know that the gradient of those two lines, when if you multiply them together, they're going to give us -1. And then if that is the case, since we have calculated the gradient of OQ, which is this one, you just substitute, then you solve for gradient of QR. Then it's going to, you're going to obtain what? A -12/5. -12/5. So that is the gradient that we are looking for that line. After having the gradient and the point, you can now write the standard equation of a straight line. Then you substitute. After you have substituted, then you simplify it until you reach to the final stage, and then it should be in the form of y equals to mx plus c. You can see our gradient is -12/5. The x plus 169/5. So that is the equation of the tangent RQ. So that is the the equation. Let's proceed. We are now under ellipse. Let's look into ellipse. And then first, we'll be plotting the graph of ellipse. Secondly, write the equation of ellipse in the standard form. Now, in a standard form, we're referring to this one here. It should be x squared over a squared plus y squared over b squared minus 1. So then we're going to be doing that with you today. And now we can see we've got two pictures of what? Of ellipse. This one, which is drawn horizontally, and then this one is drawn vertically. You can see that. So these are two different types of ellipse that we are having. It's either we have this one, which is horizontal, or we have this one where it's vertical. So it's very important. Now we're going to be dealing with that after this. And let's see what we're having. The first example Now let us sketch. Now it says sketch the graph defined by this one. Now, how are we going to sketch the graph? Let's see the solution first. Now it says when the bigger number is under x, the bigger number, the ellipse is horizontal. When the bigger number is under y, it is vertical. This ellipse horizontal as bigger number is this. Now, let us come to this equation that we're having here. Which number is bigger? It's under y. Now, if when the bigger number is under y, it is vertical, right? Now, this is the vertical ellipse. This is the vertical ellipse actually. It's supposed to be vertical there. This is vertical ellipse. Vertical ellipse. Then after plotting that ellipse, you will see that it's going to be vertical, right? It's a vertical ellipse as the number under y. This is supposed to be y, not x, right? And then now let's go. Now we can see if it's vertical, you can see this is how it should be if it's vertical. This is how it should be if it's vertical. Now you can see the point that we're going to plot here, and on this one, on this line x-axis is going to be called core vertices. Core vertices. And then the other points, which is this one and this one, then we're going to call them vertices. But only when this ellipse is vertical. But now, if it's horizontal, now it changes. These points here, they are now what? They are now called core vertices. And then these points there, they are now called vertices. So you must be aware of that. And then you must be able to know when it's going to be horizontal and when it's going to be vertical. So it will depend on these two values. Now let's proceed. We first rewrite the equation so that the denominator are shown as squares, and we can now identify the value of a and b. Now remember, if this is the case, we can't really say a is 9. A is not 9, and then as well as b. Remember, the standard equation for ellipse, it says x squared over a squared. You can see that instead of a squared, we have 9. So it does not have a square, but it shows that we don't have the value of a. Then we will be doing that. Let's see. Of course, now we know that if you say 3 squared, it's going to give us 9, meaning a is what? Is 3. And then b, 4 squared is 16. Then we can now easily see what is the value of b, which is 4 in this case. Okay. Now, these 3 and 4, we're going to use them to plot the ellipse graph. Now, the 4 points we need to plot in order to sketch what the ellipse are. First, the coordinates of the vertices, which is 0 is to 4, 0 is to -4. And then coordinates for the core vertices are 3 is to 0 and -3 is to 0, right? Then now we're going to take these points and plot them on the on what? On the Cartesian plane, and then this is what you're going to see. So this is the graph we're looking for. So this is the graph that we are looking for. You can see this graph is vertical, right? It's vertical. Then now let's go to the next question. We are still under example 2 ellipse. Now it says write the equation in the standard form of ax squared over a squared plus y squared over b squared equals to 1. Now we can see that we're having something new. It must be in this form. But how are we going to do that? Now let's see how do we go about it, my dear learners. You first write the equation, what we are having there. Now first, then because we want to have 1 there, so the only way to obtain 1 is to divide this 64 with 64 so that we can have 1. We know that 64 divided by 64 is going to give us what? 1. And then we divide every term with 64. So after doing this, and then we simplify it, this is what we want to have. Because if we say 4 divided by 64, it's going to give us 1 over 16. And you can see this 1 over 16. Then 16 over 64, 16 over 64, it gives us what? It gives us 1 over 4. You can see this 1 over 4 equals to 1. Now you can see that it is in this standard, right? But we want to see it should be in terms of a squared, b squared, not 16 and 4. Then now let us rewrite them. And of course, it's going to be 4 squared, 2 squared. You can now see the value of a is 4, the value of b is 2. So that's how you should now write the equation of ellipse in the standard form. So that is the only way you can do that. You just divide with this number here so that you can obtain 1. Okay. All right. Thank you very much. This is our end for today's lesson. Then we're having an activity under this analytical geometry. You can just take this question and try to answer them and prepare yourself for trial exam and final examination. And then, boys and girls, this is the message for today's lesson. And that says study like there's no tomorrow, because if you keep putting off your studies for tomorrow, you will probably be late. All right. Let us try not to postpone when we have to study. Make sure that every chance you get, you must utilize that chance. Study and prepare yourself before you write your trial exam and as well as the final examination. I thank you.